Okay, I'll try to move a little bit more quickly now through these next two methods. So method 2 is using calculus to create an identity. These certainly won't be identities that you would have probably previously associated with Pascal's triangle. It's certainly going to be very much a variation of what we know as a row of coefficients or as a standard binomial. So it's going to be quite a variation. And again, we would never be expected to come up with this ourselves. However, we are expected to recognise features of it which direct us to this idea that possibly a binomial and its expansion have been differentiated or integrated. So let's have a look at simply differentiating the very simple binomial 1 plus x to the n and its expansion. I'll just pause it now, write that up, and then talk about it. So you can see there we've just followed the standard rules for differentiating. We're differentiating with respect to x. Bring the power to the front, subtract 1 from the power. Differentiate a constant, it disappears. Bring the power to the front, subtract 1 from the power, it goes to 0. So we just get NC1. And that, like I said before, sometimes in these identities, which this is actually an identity. It's different to the identities we saw before because we still have an x term in this identity. That doesn't mean it's not an identity. You can have an identity still with the x term in it. The fact that the NC0 disappeared it's only a minor feature here, but it is still something that you should recognise has happened. There are many other features you should recognise as well and will become a key feature for you to recognise, in that we've got what was solely in an index position now taking place as a coefficient. So that clearly would indicate to you that, well, this is something we see when we differentiate, where the power comes to be a coefficient and the power is decreased by 1. So you can certainly see that occurring here. And this has just been differentiated. The powers have come to the front and the x power has been decreased by 1 all the way through to the end. So there's nothing difficult with the differentiation, but it's just the fact that, I suppose, we've been differentiating. It's unusual to differentiate, I suppose, in this situation. But know now that if you see this feature, then hopefully you'll make the connection to differentiating. Sometimes this identity is written in sigma notation. Now, it's not the only identity that could be written that way. There's nothing special to these particular types, but if it is written in sigma notation, note that the k value starts from 1, which is also, I guess, the feature here in the identity, that the counter of the coefficient was at a 1. And you could say, oh, but hang on, back in the substitution example 2, the U try 2, the NC naught disappeared as well. Yes, it certainly did. And that's where, I said very early on in the videos that you got to be very flexible with these features, because something that I've identified as maybe as a feature or an element of an identity may appear elsewhere, but you've got to have something that you're focusing on or looking for in order for you to be able to categorize these. But yes, it's certainly now you're putting this example into your running sheet, and we've moved on to type 2 calculus, and you could write this one up and even write it in its sigma notation. Now, you may see identities that are a result of differentiating, but they have also had a substitution. So it's like it's had two things happen to it. The binomial and its expansion were differentiated, and then a substitution was made. Now, this is certainly going to produce yet again another identity. I'll just pause the video again and complete that and then talk about it. So substituting x equal to 1 into this identity, then we get n2 to the n minus 1 is nc1 2 times nc2 3 times nc3 and so on. So if this was the identity that was given with the instruction of show or prove that this identity is true, then hopefully the features of it, which would lead you to knowing that you need to differentiate, are still this feature of a power appearing now as a coefficient and 1 being subtracted from the power, which is certainly a feature of differentiation. And on this side, still supporting the idea of differentiating in that a constant, when differentiation is applied, disappears. So yes, our NC naught disappeared, and we're seeing that powers are appearing as coefficients. And interesting here that these coefficients are increasing, just as the power would have been increasing. However, we don't have an x term. We don't have any x terms over here. So you can see the additional step in creating this identity is to also substitute x is equal to 1. So it's like there are two methods involved in creating or showing this identity. So I would say that in both of those, which you'll need to add to your running sheet, in both of those identities, and please include the identity in sigma notation, it would be the presence of this, the nx to the n minus 1 with coefficients nck appearing on the right hand side that would alert you to the method of differentiating.